Welcome back, Wisdomers. Today we explore how slope behaves when equations become nonlinear. We will also provide an introductory look at differentiation, which serves as the bridge to more advanced topics. It is important to remember that these concepts are the fundamental building blocks for understanding machine learning and deep learning. Stay tuned until the end, as mastering this intuition is the first step toward understanding how neural networks actually learn. To understand how nonlinear functions behave, let's analyze the quadratic function y equals x minus 1 squared. At x equals 2, at this point, the curve is rising at a moderate incline. At x equals 5, notice how the steepness has increased significantly compared to x equals 2. At x equals 1, the curve is perfectly horizontal, there is no slope. One has to understand, slope varies at each point in nonlinear functions. Before we move on to important concept differentiation, please share, subscribe and visit www.wisdomers.in for quizzes and projects. At this point, a fundamental question arises: how do we mathematically determine the exact slope of a curve at a specific point? We use a core tool of calculus called differentiation. Let's calculate the slope of the quadratic function y equals x minus 1 squared at the specific point where x equals 2. Using the power rule, dy by dx equals 2 times x minus 1. To find the slope specifically at the point x equals 2, we substitute 2 into our derivative formula. Slope equals 2 times 2 minus 1, which equals 2. Don't stop. There is a critical second insight that the slope provides. The slope will find the direction the function is moving. Example: at x equals 5, the slope is plus 8. A positive slope indicates that the function is increasing. As x increases, y also increases. The curve is moving in an upward direction. At x equals negative 5, the slope is negative 12. A negative slope indicates that the function is decreasing. As x increases, y actually decreases. The curve is moving in a downward direction. These fundamental principles of calculus serve as the primary building blocks for the complex architectures found in machine learning and deep learning. We wish you an insightful and successful journey as you explore the frontiers of artificial intelligence.